Hello students, now we'll start with next part, that is polygon clipping algorithm. In last part we have saw what is how to clip a line using line clipping algorithm. Now we will see how to clip a polygon. Basically polygon is a set of lines only, right? Any polygon is made up of lines, but the main difference is it is a closed figure. So here also we can use line clipping algorithm to clip a polygon, is it? Now suppose if we are using line clipping algorithm, then each line of polygon is separately considered and clipped. After clipping, we will get again a set of lines. But can we call that set of line as polygon? No, because these lines are not forming a closed figure. That is why we have to modify the line clipping algorithm. So for polygon clipping, we require an algorithm which will produce a closed figure after final result, right? Now clipping a polygon may produce a polygon with fewer vertices, it is possible, or one with more vertices than the original one. It may even produce several unconnected polygon, right? So the polygon clipping algorithms which are available are basically Sutherland-Hodgman polygon clipping and Wheeler-Atherton polygon clipping, also called as generalized clipping. First we'll see what is Sutherland-Hodgman polygon clipping. Now Sutherland in this. What is Sutherland-Hodgman? Sutherland-Hodgman polygon clipping. We can clip a polygon by considering the whole polygon against each boundary edge of the window. We know that to represent a polygon we need set of vertices, right? Now we will pass this set of vertices or polygon to a procedure which will actually clip or omit the polygon against left edge of the window. Now first we'll go for the left edge. This left edge procedure generates new set of vertices which indicate left side clipped polygon. Again now this new set of vertices is passed to the right boundary clipper procedure. Again it will get new set of vertices, then we will pass this new set of vertices to the bottom boundary clipper and lastly to the top boundary clipper. Now let's see this image. Now here we see the four different stages which are required to clip a polygon. At the end of every clipping stage, a new set of vertices is generated and this new set or modified polygon is passed to the new clipping stage. After clipping a polygon with respect to all the four boundaries, we will get final clipped polygon. Now when we clip a polygon with respect to any particular edge of window, at that time we have to consider following four different cases. As each pair of adjacent polygon vertices is passed to window boundary clipper. So now suppose we'll take this as it is drawn here, we'll take this as an example and we'll start with this. So we'll start first with left clip, right? This is the sequence which is to be followed. Input polygon, left clip, right clip, bottom clip, top clip, right? This is your image. So first is left clip, the left side is clipped, then right side is clipped, then bottom is clipped, and then top is clipped, and this is the final outcome. So left clip, right clip, bottom clip, top clip. Now this is your given image. We have to follow the same procedure, that is left, right, bottom, top. First it will go in the left clipping. After the new image which is found will go for right clipping, right? So here this is the given image. We'll start for this. Now here first is left clipping. So consider the line for left clipping, consider line AB. Now what will be for AB? Left clip is to be done. Now here the left side only will be get clipped. So left side stands for A. Now A to P will mark A to P1, P5 and B, right? Though the polygon is A to B, we have to mark here it will get clipped till where it intersects. So we'll mark this point as P1. Okay, so A to P1 is to be clipped, and the new point which we'll get for line AB, the visible portion right now is P1 and B after left clip. Then similarly for BC, B and C, nothing will be clipped. So we'll write it as it is, that is B and C. And for the line AC, now what will clip for line AC? We are following just left clip. Again point A to C is to be clipped. So the left portion which is outside is to be clipped. We will write this as suppose P2 intersection point. A to P2 will be clipped and the new points will be P to C. So now we can say that this portion is basically clipped after left clip. The new portion images P1 B6, P1 to B, B to C and C to P2. This portion is clipped after left clip. Similarly, next will be right clip. After right clip there will be no changes as right portion has nothing to clip. No portion is outside the window. Next is, what is next? Left, right, bottom, top. Next, after bottom clip, similarly this portion will get clipped and the remaining portion will be P1, P1, P2, P4, P3 and B. And lastly, that is top clip. This portion will be clipped and final polygon which we'll get is P1, P2, P4, P3, P6, P5 after every clip, right? Now what is the drawback of this algorithm? In this algorithm, the problem of extra edge occurs since we are storing all the vertices in a single vertex list, and to form a closed figure we are forming an edge between last and first vertices. To overcome this problem, the next algorithm is used. Now what is the problem? As we see, for each array, for each line we are storing the data, and so the array goes on increasing after every clip. This problem is solved in the next algorithm, that is Wheeler-Atherton polygon clipping. Now what is Wheeler-Atherton polygon clipping? This algorithm is one of the generalized polygon clipping algorithm. It is considered to be better than Hodgman polygon clipping, and the technique is basically simple, and the edges, the main technique it is we have to consider each generalized line is same, the base is same, just the way of putting the data in the array is little bit different. Now, but what is this in this case? Excuse me. Yes, we'll start with Wheeler-Atherton polygon clipping. As we know, this algorithm one of generalized polygon, and in Sutherland-Hodgman algorithm we have already seen that we always follow the path of the polygon. But in this case, sometimes we are selecting polygon path and sometimes window path. So in Wheeler-Atherton polygon, we have to consider, depending on the direction, basically we have to follow either the polygon path or the window path. Now when to follow which path? It depends on the polygon processing direction and whether a pair of polygon vertices currently being processed represent an outside or inside pair, right? So we can follow this process in clockwise or anti-clockwise. If nothing is mentioned, we'll always go for clockwise. So the steps to follow are, we have to follow the polygon boundary, same as that of Sutherland-Hodgman algorithm, right? Each line is to be considered if the vertex pair is outside or outside to inside. You're getting the point? If the vertex pair is outside to inside, we will follow the polygon boundary, and we have to follow the window boundary if the vertex pair is inside to outside. So we have two basic rules. If the vertex pair is outside to inside, that is obviously outside to inside in terms of window we are talking. Outside to inside, follow polygon boundary. If the vertex pair is inside to outside, follow window boundary. Now we'll consider this example. Here the directions are given, so consider this for line AB. AB is outside to inside, right? Line AB is outside to inside, as the window is in the left hand side, right hand side, so the direction will be outside to inside. And for outside to inside, what we do is we follow polygon boundary. So for AB, the polygon boundary will be obviously, inside part will be P1B, right? Now next is BC. For BC, it is inside to outside. For inside to outside, we follow only the window boundary. So for inside to outside, that is BC1, we find the intersection point as P2. We have to find it, and we have to mention only the polygon boundary, that is B2, right? B2, and the previous one, that is for B, is P1. You can write P1 or you can directly write only P2, that will also do. So for AB it will be P1B, for BC it will be P2. Now for CD it will be, again it is from outside to inside, so we have to consider the, yes, for outside to inside we have to consider the polygon boundary, so it will be P3D. Now again for D to E it will be window boundary, so that is P4. Here I have written P4 and P3, that is previous one, to show the connectivity, but even if you write P4 it will do. And lastly E to A, it will not be considered, right? So as it is not intersecting with the window anywhere. So the given points, so the data which you get is P1B, P2, P3D and P4, right? So these are the visible portion which you will get. Next is text clipping. Now we know that we cannot use line clipping or polygon clipping method to clip message or text. There are several techniques that can be used basically to provide text clipping. The clipping technique used will depend obviously on the method used to generate the characters. So the text clipping techniques are, first is all or none string clipping, second is all or none character clipping, right? So first we'll start with all or none string clipping. This method of text clipping is basically simpler one. The example is there in front of you. Now it is before clipping and after clipping. Actually you can easily understand from the given example. The name suggests all or none string clipping. Either we have to delete or omit, or we can say clip all the portion or no portion to be clipped. So in the image we can see in before clipping A, B, C, D and PQR are two strings. Now A, B, C, D portion A is outside the window while PQR is completely inside. So PQR will be kept as it is, and A, B, C, D, A part is to be clipped, but the rule is all or none string clipping. So obviously complete string is to be clipped, and after clipping we get PQR, right? You're getting the point. Let's repeat once. Now in this case a rectangular box is created around a string. The boundary position of this rectangle is then compared to the window boundary, and the string is rejected if these two boundaries are overlapped. Here the main drawback is basically if a single character of the text is outside, then we are discarding the whole text. If the rectangular box of the text is completely inside the window, that is all characters of text are inside the window, then only this text will be displayed. Now this method is fast but it is not efficient. as you have seen in this above image. If in the two strings are ABCD and PQR, string PQR is completely inside the window, so it will be displayed. Whereas in case of string ABCD, only one character is outside and rest three characters are inside. Still we are rejecting the whole string. Okay. Next is all or none character clipping. This technique provides actually alternate way for text clipping. In this case, instead of rejecting the whole string, as the name suggests, we are clipping the character. We are discarding only those characters that are not completely inside the window. Right now, in this case, the boundary limits of the individual character are compared to window. The character which either overlaps or lying completely outside the window gets clipped. Did you get the point? The character which overlaps and outside. So in both the cases it will be discarded, whether it is overlapped with the window or it is outside. Now in the given example we can see the string man is completely inside the window, so obviously it will get displayed properly. But for string space, first two characters are outside the window and next three characters are inside the window, and the condition is all or none string clipping technique, right? So we are discarding in all or none string, we are discarding the whole string, right? Because the rule was to discard all or none, but in this case it is all or none character clipping. So here we'll not consider the whole string as one, we will consider each character as a single unit. And so for this, for discarding only two characters will be sufficient, as we are considering every character in a string as different units. So we'll discard S and P, right? So the new after clipping will get ACE and man. Now next is copy. The character C is completely outside and character P and Y are completely inside, but character O is partially outside and partially inside. So what we'll do, we will clip both C and O, as the rule is we'll clip that character which overlaps or is lying completely outside, right? So after clipping we'll get ACE, PY and MAN inside the window, which will be displayed properly. There is actually basically a third way by which we can clip the text. Here we can say that a third way in this, here we can say the method is to deal with the components of actually individual character and treat the character as set of lines or pixels also. But these are the main two techniques which we consider, that is all or none string clipping and all or none character clipping, right? Now the last portion of the unit is interior and exterior clipping. So till now we have seen whatever clipping techniques we have seen is interior clipping, right? It means we are displaying the object or portion of object which is inside the window and we are discarding the portion which is outside. But in exterior clipping we are doing exactly reverse of interior clipping. Now see in the given example, in case of exterior clipping we are discarding the object or part of object which is inside the window and displaying the part which is outside the window. The exterior clipping is mainly used in multiple window concept. So this is the original image, and interior clipping, what we do, whatever is inside is kept and the outside part is discarded. But in exterior clipping the inside portion is discarded and whatever is outside is to be displayed. Okay.